Let's say we want to plot an irrational number root 2 on the number line, right? So far numbers were easy to plot, the rational numbers were easy to plot because we had them in the form p by q. Now we don't. So how do you plot root 2, right? So let's take a number line. The simplest way to plot it is from 0. I'll take 1 unit here, 1 unit this side on the positive side of the number line and 1 unit on top, right? So I have 1 unit here and 1 unit on top. Now what will the length of this diagonal be? Root 2, simply because of Pythagoras theorem. Because if you look at this triangle, in this triangle, one side is 1, the other side is 1, right? So the third side or the hypotenuse will be nothing but square root of 1 plus 1, which is why root 2, correct? Which is why the hypotenuse is root 2. Now just take a compass, right? Keep it on the origin, the other end on hypotenuse, and plot the hypotenuse, right? Keep the radius constant, plot the hypotenuse on the number line. So you have your hypotenuse on the number line. The hypotenuse is nothing but root 2. That means this distance is root 2, right? That's how you'll plot root 2 on a number line. Simple, using Pythagoras theorem, right? This side is 1, this side is 1, this is root 2. As simple as that, right? So you have root 2 now plotted on the number line. Let's say you now want to plot root 3. How would you do that? For root 3, look at this triangle again, right? We had 1 plus 1, we got 2. If we want 3, how will we get? 2 plus 1 will give us 3, right? And 2 is nothing but root 2 squared, right? So in the same triangle, if I change this side to root 2 and keep this side as 1, then my hypotenuse will be 3, right? Because root 2 squared is 2 plus 1 squared is 1 will give you 3, right? Now we've already plotted root 2 on the number line. Let's use the same root 2. So you have root 2. Draw 1 from here. So you have a triangle, one side root 2, the other side 1. The hypotenuse of this triangle is going to be root 3, right? That's how you get root 3. Now you can go on and on and on, and you can plot the root of any number. So that's the way you will plot square roots on a number line, right? We can have root 4, root 5, root 6, and so on, right? Root 4 is anyway 2. It's easy. So all irrational numbers which are square roots, you can plot this way. Now there's another interesting visualization for these same square roots. Now I have all of these triangles side by side. Instead of having them like this, let me rotate them. Let me keep the first triangle as it is. The root 3 triangle, I'm going to rotate it so that this root 2, the root 2 that we had on the horizontal line, coincides with the root 2 that I had on my hypotenuse, right? So I rotate the root 3 triangle. Same way I rotate the root 4 triangle, right? So that the base of the root 4 triangle coincides with the hypotenuse of the root 3 triangle. And similarly, I rotate all of the other triangles, you'll see a spiral getting formed, right? You'll see a spiral getting formed. You'll see if you add all of these, they form a spiral, correct? So that's another way to represent or visualize square root.
If you like this video and want to watch many more amazing videos like these, like and subscribe to our channel now.